Hello folks, thanks for tuning into AI Probably. My name is Swagat Panda and I am your instructor for this course, Numpy Beginners Bootcamp. Okay guys, let's begin the course. Here in this course, first we'll know about what is Numpy and then we'll get into the details why it is needed in the field of data science. Then we'll cover the Numpy array. In this Numpy array is a broad topic. So in the latter part of the Jupyter notebook, we'll cover out what is there and how we can which subtopics we'll cover on Numpy array. Then we'll have a demo of it. Okay. NumPy. What is NumPy? NumPy is basically a linear algebra library for Python which support large multidimensional arrays and matrices along with large collection of high-level mathematical functions to operate on these arrays. Okay, so basically on whatever the operations we perform on array or matrices, on vector or matrices, that we can compute easily using NumPy. Okay, then come to the next part. The need of the NumPy in the field of data science. If you have any time dealt with any neural network or any machine learning algorithm, you must know that all the machine learning algorithms used numbers or arrays as an input. To make that array, the NumPy is one of the most commonly used element. So NumPy is a very useful for performing mathematical and logical operations on array, and in almost all the PyData ecosystem rely on NumPy as one of their main building block. So it is one of the vital part in the field of data science. Okay, now let's move to the next part of the section, that is NumPy array. In this section, we'll deal with how to build a NumPy array, their built-in functions, their logarithm and trigonometrical functions, and we'll also learn about how you can perform any arithmetic operations over NumPy array. So basically we have given a pictorial representation of the NumPy arrays, but you can perform they are broadly classified into two categories, that is a vector and a matrices. So here is a simple definitions of NumPy array. A NumPy array is simply a grid that contains values of the same type. Okay. From this definition, you can easily distinguish between a Python list, a Python simple list, and a NumPy array. Okay. Okay. NumPy array usually is basically broadly differentiated into two different parts. One is a vector and another is a matrix. Vectors are strictly one-dimensional arrays. Means they will be 1 cross n of size, okay, or n cross 1. Okay, means they have only one row or one column, while matrices are multi-dimensional. Okay, and matrices can still have one row or one column. Okay, so this one is an example of a scalar, which is a number, direct means completely number. Okay, this is a vector which is 1 cross n, and this is another vector of n cross 1. Here n is 3. Okay, and here and this one is a matrix. Okay, we'll get a brief about this NumPy array on the code section. Okay, now let's jump directly into the Jupyter notebook and explore this world of arrays that is in Python, that is NumPy. Okay, let's start with our demo. By the end of this section, you will be able to create a NumPy array and perform basic operations over NumPy array. Okay, in this first section, we'll cover how to create a NumPy array and their attributes and methods, and we'll see different type of NumPy operations. On the section of creating NumPy, we have two different parts. First part, we'll see how we can create a vector or a matrix, that is a NumPy array, from a Python list. And second part, we'll see how we can use the built-in methods that are provided by the NumPy to create different type of NumPy arrays. Okay, now let's start to build a NumPy array from a simple Python list. Before jumping to the NumPy, we have to import NumPy. Here I am using a collab file. So in collab the NumPy is already installed, so you don't have to install it. But if you are running it on a normal Jupyter notebook on a local system, then you can use pip install NumPy in your Jupyter notebook, and by running this shell the NumPy will be installed. Okay, so now comes importing part of the NumPy. Import NumPy as NP. This is a standard format as NP we used all over the code. Means in any code you might have used, NP is used as the alias of NumPy. But in spite of NP, this is your choice that you can use anything. You can write KL, NPPP, Iron Man, or anything. Okay, but the standardized format is NP. Okay, fine. Now let's jump into it. See, this is list 1. We have initialized list 1 with 10, 20 and 30. So as you know that this is a simple initialization of list in Python. So if you check the type of the list, type of list 1, it will show that this is a list. Okay, we have to convert it into a NumPy. So this is a simple command to convert a list into NumPy, that is np.array. So if you check the type of that list which you have created, it will be numpy.ndarray, that is n-dimensional array. In the similar way, you can create a matrix out of in simple Python list of list. This you can see a simple matrix created with Python list, that is a list inside the list. So we have created a 3x3 matrix here, but this is a list now also, because if you check the type of that matrix, this is a list, not a NumPy array. So in the similar way, if you put np.array and pass this list of list, then you will get the NumPy array. If you further check the type of it, it will be the same type. Clear? This is a NumPy n-dimensional array. Okay, now it comes to the second part of the NumPy creation, that is the built-in methods. Here we'll discuss different types of built-in methods through which you can create an array or a matrix, a vector or a matrix of NumPy array. that will be the same ND array, n-dimensional array. So here we can't discuss all the different built-in methods, so some of the important built-in methods we'll discuss. So let's start from the arrange method. This method returns evenly spaced value within the given interval. This works same as the range function, which returns a iterator and which you convert to the list. You must have be familiar with this function. Let's say we have to build a 1 to 10 list. So this arrange functions works similar to it, but instead of returning an iteratable object, it returns a numpy array. So let's see this np.arrange 0 to 10. This will create an evenly spaced values from 0 to 10 with a default interval for this range will be 1. So here we get 0, 1, 2, 3 which have an even distribution of 1. Then let's say we want to have from 0 to 11 with an interval of 2. This will be the array for it. Let's say we want to get to the -2. Then there will be it will return a array of length 0. In the same fashion, if we make it from 0 to -11 and -2, so it will be in the negative side of the number system. As you can see, the array is 0, -1, -4, -6. Here it is increased by -2. Okay. Then next we goes to zeros and 1 function. Okay. np.zeros gives you a array of zeros. Okay. This method can be used in various machine learning algorithms for normalization or any related stuffs. So np zeros, let's say you passed only 5, it will give you a 1 cross 5 thing. If you want to check the shape of it, you can apply dot shape method to it. So to construct a matrix of 3 cross 2, you have to send a tuple, that is 3, 2 to the np zeros function, and it will return a matrix. If you want to check the shape of it, you can go ahead and check it like that. The same functionality is applied to ones also. So the same thing, if you instead of zeros you directly push ones, and in ones also if you want to have a matrix, you will have to send a tuple. Okay. Now let's move to another built-in function, that is linspace. This function is used in various kind of methodology. While going beyond in this section, you will see the use of this function. So this method returns evenly spaced number over a specific interval. Let's say you want 0 to 10. From 0 to 10 you want 4 numbers. So it will return an array of 1 cross 4, but the complete thing will be evenly spaced. Okay, you can have a broad example. When you are seeing this one, you are getting all the numbers from starting from 0 to 10, and inside that it is a 50. It is not a matrix, it is a vector itself, because it's a 1D array. You can check out the space of it. shape of it, that you can see this is 50. So this is a vector. And another built-in function you can have, that is a UI method, that is identity matrix. If you want, you all know that identity matrix is a squared matrix. So you have to send a particular number and it will return a squared matrix of a squared identity matrix. Let's say you passed 5, it will give you a 5 cross 5 identity matrix. So if you pass, let's say 6, it will give you a 6 cross 6. Okay, now let's come to the next part of the video, which is we have now come know how to make an NumPy array. So now let's discuss about the different type of attributes and methods that are available for NumPy array. The basic attributes and methods, let us discuss it. So for this course, for this part of the block, we have to define two vectors, AR1 and AR2. As we have already discussed about the arrange function, so it will act like a range function in normal Python. So it will give us a vector of 1 cross 36, that is a vector. And the second AR2, this argument will return as a vector of 1 cross 10 with the numbers from 0 to 100, and it will be linearly spaced. So you can see AR1 is from 0 to 35, as it is 36. So you can check the shape of it. It will be 36. And similarly, as we have discussed, AR2 will be of 10th length. Okay. Now let's come to the different type of methods. So the max method, as the name suggests, max method gives the maximum of that array. Like in ARR1, if you check, the maximum is 35. In AR2 it is 90. Fine. Then comes the minimum method. As the name same suggests, the minimum gives the minimum of the array. So in AR1 the minimum is 0. In AR2 also the minimum is 0. So if you change 2 of minimum, it will return as 0. That will not make any sense, because if we create an array, let's say, for if you want to see the minimum, let's create a list 1. Four, 8 and 7. Okay, so now let's we convert it to an NP array. So the NP array of list 1 will return us an array. So on that array we use the minimum function. See, this returns the function. So let's call it, we got the minimum, that is 4. Okay, this is clear. Then we move ahead, and this is the two different functions, argmax and argmin. This function return the index of the maximum number or the minimum number. Let's say in the array 2 the maximum number is 90. So let's go to the slide that will give you a better understanding. See this part. So here the arc min will return the zeroth, means that is the index value of the 1, and here the arc max will return 5 where the maximum number is 6. Similarly, you can see here that when you apply max on 90, that is 90 maximum number, and that index of that 90 is 9. Similarly with mean, it will return 0. 0 is the minimum number and the index of 0 is also 0, so it has returned 0. Fine. Let's come to resave. So our error 1 is of 1 cross 36. Let's check it out. 36. So when let's say we want to convert it to a matrix, let's convert it to a squared matrix. So this 36 will be 6 cross 6. Hence we applied dot reshape and to that array, and we got the shape of it, that is 6 cross 6. Okay, now we have arrived to the last part of this video, that is the NumPy operations. Here we are only discuss about all the type of arithmetic operations which you can perform on NumPy arrays. Okay, let's go through it. As you remember, in the previous block we have already initialized the array 2. So let's run it. So you can check it out. The value of array 2 is 10, 20, 30, 40, 50, 60, 70, 80 and 90. Okay, if I add them both, means array 2 plus array 2 means an array of this will be added with the same. So it will just return 0 plus 0 equal to 0, 10 plus 10 is equal to 20, and like that. If you subtract, then you will get 0 because it is element wise subtracting and it is element wise addition. So then it comes multiplied by 2. Then all the elements of array 2 will be multiplied with 2. 0 multiplied with 2, 0. 10 multiplied with 2, it's 20. 20 multiplied with 2, it's 40, and like that. Then it comes the array 2 multiplied with itself. So 0 will be multiplied with 0, 10 will be multiplied with 10, 20 will be multiplied with 20, and this is the result. Then the same way, if you add plus 2, then 2 will be added to each element. You subtracted 2, then 2 will be subtracted from each element. Okay, this symbol implies power, so each element will be power to 2. 0 to the power 2 is 0, 10 to the power 2 is 100, and so on. So now it comes, we are dividing array 2 with array 2, so each element will be divided by itself, means 0 will be divided by 0, 10 will be divided by 10, and so on. Okay, but as you know that anything divided by 0 is not a number, so it will be not through an error, but with a simple warning. It will say invalid value encountered in true divided, and it will return a nan. Okay, and 1 divided by 0, in here all the elements will be divided by 1. So 10 divided by 1, 1 divided by 10, it's 0.1, and so on. But when it is divided by 1 by 0, it returns infinity, which is correct. So Thanks for watching this video, and this is the end of this tutorial. Thanks.